Welcome to lesson 3.4, multiplication of radical expressions. So we're going to use the distributive property. We're going to simplify things at the end, leaving answers in mixed radical form. And we're going to remember that when we're multiplying two square roots that have different radicands or different guts, we just multiply the roots. So let's take a look at the first question. Question 1, I've got root 2 that needs to be distributed onto root 6 and then on minus root 8. So if we were to write this out, we would get root 2 times root 6, or you could write it as root 2 times 6. Either way, you're going to get root 12. That's going to be subtracted by root 2 times 8, root 2 times root 8, which is root 2 times 8, which is 16. And now we have to simplify. So 12 I could write as root 4, because 4 is a perfect square, root 3, or 2 root 3. That's the whole reason why I would pick a 4, because it turns into a 2. And then 16 is nice because it is a perfect square, so to be the square root of 16 is just 4. So the final answer is just 2 root 3 minus 4. And I know it looks weird, but we would just stop right there. Question 2, we're going to distribute some more. So to distribute the root 5 onto both of these. And remember, inside times inside, outside times outside. Coefficients multiply together, the radicands multiply together. So this would give me root 5 times 10, or root 50, which I notice has a root 25 root 2. And I can simplify that to 5 root 2, because 25 was a nice perfect square, minus 2 stays out front. Inside, I get 5 times 7, which is minus 2 root 5 times 7 is 35. And there's no perfect square hiding in there. There's nothing we could do. We would just do that and we would stop. Because the radicands don't match. These guys don't match, so we stop. We can't combine them. Question 3. Question 3, we're going to be distributing 3 root 5 onto both of these. And we're going to have to make sure that we pair outside with outside. So for the first 3 root 5, 3 stays outside. And then inside the square root is going to be 5 times 15. I'm just going to figure out what that is first. So that's 3 root 75, or 3 root 25 root 3, which is 3 times 5 root 3, or 15 root 3, because we got a nice perfect square that was a 5. My second distribute, the second red arrow, outside times outside is going to be 3 times 2, and inside is going to be 5 times 2. So I'm going to get 6 root 10, and that can't be simplified. We can't find a hidden perfect square inside of root 10. And so we go, and root 3 and root 10, the radicands don't match, so we stop. Question 4, distributing root 3 onto both of these. So I get the square root of 3 times 27, which gives me the square root of 81. Oh, that's nice. It's just 9. Plus 4 is outside, stays outside. Inside, we have 3 times 6. I could write that as 4 times root 18. 18 has a perfect square hiding inside it. It has a 9, so root 9, and then root 2 would be left. And I do all this. 4 was outside. When we take the square root of 9, that turns into a 3, and that would be multiplied by the 4 that was out front. So that would give us 12 root 2 plus the 9. For question 5. Question 5, we're going to have to double distribute like we've done before. So 1 onto 2, 1 onto root 5. So let's deal with that first. That gives me 1 times 2 is 2. 1 times minus root 5 is minus 1 root 5. Then I'm going to have 5 times 2 and 5 times, root 5 times 2. Let's do that. Root 5 times 2 It's going to give me plus 2 root 5. Plus root 5 times minus root 5 is going to give me a minus. Plus times a minus is a minus. And then it's going to be root 5 squared. I notice that this has both have the guts of root 5. So that's 2 minus 1 root 5 plus 2 root 5. I end up with plus 1 root 5. I also notice that I've got the square of a square root. So those cancel each other out and just leave me with 5. And now I can still combo the 2 and the minus 5. Collect like terms. So I get minus 3 plus, and I'm not going to write that 1. I'm just going to write 3 plus root 5. And we'd stop there. Question 6. Question 6 has stuff in brackets squared. So it's trying to muck you up. We are going to just remember, though, that whenever we have something squared, we're going to write it out twice. So that's really 1 minus root 3. Close the bracket, and then write it again. 1 minus root 3 inside brackets. I'll distribute. From this, 1 times 1 is 1. 1 times negative root 3 is negative root 3. From these two, minus 3 times 1 gives me minus root 3. And then minus times minus is a plus, and then I get root 3 squared. So I see that I have 2 like radicands that I can combine. So I get 1 minus root 3 minus another root 3 gives me minus 2 root 3s. But then also, I can see the square and the square root that cancel each other out. So that's just a regular 3. And now I can collect these like terms because neither of them have square roots. So I get 4 minus 2 root 3. I think we're on the next page. Next page, question 7. It's going to be another double distribute. So root 3 times root 2 is going to be root 3 times 2, which is root 6. The next one, this 3 stays outside, so minus 3 outside, and then inside is going to be 3 times 3. So minus 3 root 9. That's going to be just minus 3 times 3, which is 9. I hope you followed that. So that 9 was that. We still have the root 6 at the start. But this is a double distribute, so I got to remember to do these ones as well. So plus 2 stays out front. Inside, really, I'm going to do it a different way for this one. Root 2 times root 2 is root 2 squared. And you might remember that the square and the square root cancel each other out. So this would be the same as plus 2 times 2. So that's going to be a 4. The final distribute, that final green arrow, plus 2 times minus 3 because the coefficients multiply together. So that gives minus 6. And inside is 2 times 3. So minus 6 root 6. Now we have some like terms that we can combine. So I have this root 6 minus 6 root 6s. It's like there was a ghosty 1 here. So that's going to give me minus 5 root 6s. And then we have minus 9 plus 4, which gives us minus 5. 2 more to go. Double distribute. Root 7 times root 7 is root 7 squared. Oh, root 7 squared is just 7. Then for the second pink distribute, multiplying, it's going to be plus 3 on the outside, and inside is going to be 7 times 2. So that's going to be 3 root 14. For the first green distribute, minus 3 root 2 times root 7. Minus 3 is out front, 2 times 7 inside. Oh, so it's not going to be 2 times 7 anymore, it's 14. And for the final distribute, minus 3 root 2 times plus 3 root 2 is going to give us a minus. 3 times 3 is 9, and it's going to be times root 2 squared. Root 2 squared, though, is just 2. A reminder, oops, that was supposed to be yellow, that this just turns into 2. So we get 7 plus, oh, while we're at it, let's collect these like terms. Plus 3 root 14, take away 3 root 14. That equals 0 root 14s, which eventually we won't bother to write, minus 18. So 7 and minus 18, that'll give us minus 11. And we're not going to write 0 root 14s, so we'd be done on that one. Last two. I think I said last two last time, but I was wrong. Really last two. Double distribute. So root 5 onto root, multiplying root 3 gives root 5 times 3, which is root 15. Can't simplify. Second distribute is root 5 plus root 5 squared, so that's just plus a 5. Minus 3 root 3 times root 3 is going to give us minus 3 on the outside, and then a root 3 squared. So that's minus 3 times 3. And then the last distribute is going to be minus 3 on the outside, and inside is 3 times 5, so minus 3 root 15. So we can collect some like radicands. That's really a 1 root 15. Take away a 3 root 15 is minus 2 root 15 plus 5. Minus, that's going to be minus 9, right? Minus 9. So plus 5 minus 9 gives us minus 4. So minus 2 root 15 minus 4. This last one. I'll do it, but I'm not going to expect you guys to be able to do this stuff. But just in case. For the first one, outside times outside. So that's going to be 3x times 2x. Inside times inside is just going to be a square root x. That would give us 6x squared root x. The next distribute. Outside times outside, so minus 3x. And then I'm going to have a root x squared. So that's going to be minus 3x just times a regular x. That came from here. So that term's going to be minus 3x squared. And I'm just writing out that first one again. Okay, second part's of distributing. Minus 2x times 2x gives us minus 4x squared. Ooh, we're going to be able to collect like terms there. And then this last distribute is minus 2x. Minus times minus is plus 2x on the outside and a root x on the inside. And I would not be surprised. Oh, it doesn't combine. So the only things that we can combine here that are like terms, we have a minus, we have these 2x squared. So minus 3x squared minus 4x squared gives us minus 7x squared. Right here I've got x square root x, and then I've got x root x. Those don't match. And because they don't match, we can't combine them as like terms, so we keep them separate. So 6x squared root x stays there, plus 2x root x. And I checked my answer. Ooh, got that one right, got that one right. I'm pretty sure I got the rest right. So thanks for watching it, and I'll see you in the last lesson.